compiled Python programs, your compiled Java programs, but they allow for a lot more flexibility, and they also allow for, how do I put this? More interesting use cases because of their uncompiled nature. Um, we're going to focus on bash scripting. Um, if you want to learn Python or Perl, there's plenty of great resources to do that. If you want to learn batch scripting, which is Windows command line, or PowerShell, Windows and Microsoft has a lot of great docs for that. Plus, a lot of it carries over from Unix Bash shell, so it shouldn't be that hard. Just some syntax changes. So basic syntax, you have variables like most languages. You can assign variables, give them a value, and then you can use variables. So you define a variable. Variable 1 is 12, variable 2 is string hello, and then you echo out. You can use echo, which is just a print statement, prints right to the command line, and you can print a variable. Now, there's two ways to use variables, and one is just double quotes. Substitutes the variable value straight up. So if you did echo var1 in double quotes, it would var1 is 12, it would output 12. If you do single quotes, it will literally put $var1. Or in the case of this example, $var. That's what it'll do if that was single quotes, not double quotes. Simply because there's, Bash decided to make a distinction between double and single quotes. Some languages do this, not a lot. I think batch scripting, this is one of the differences. They don't care about single or double quotes. The other thing that's really important to note about syntax is you don't have to worry about white space in bash scripting. So yay for all of you who hate Python for that reason. All you have to do is make sure each variable definition, each function, each part of your conditional statements, all of which we'll get into later, are all on separate lines. Bash is line by line. If you want to have things on the same line, then you got to use the semicolon. That way the script knows where you're meant to be stopping. So yay, no white space, yay, no weird curly braces. So there's also some special variables, and these are all your arguments. So $0 is the name of your script. $1 through 9 are your arguments. You can also do 10, 11, 12, so on and so forth. $@ is all the arguments that were passed. $hashtag or $$ is the number of arguments. $? Is the return code of the previous command. So if the previous command that was run gave an error, for example, you tried to run the you tried to run apt-get without being sudo, gives you the error, oh, you're not a super user. This will return that return code, that output. $$ is the process ID of the running script, which can be very useful for killing processes, which we'll get into a little bit later. Exclamation point is the entirety of the last command as you typed it. And $_ is the last argument of the last command. I tried to look around as to why this one was added and why this would be useful. And this is just one of those weird things that was just left over, as far as I can tell. One of those like archaic things that was useful, but nowadays people don't utilize it as often. Also, a lot of these special vars, they won't. A lot of bash scripting will work if you type it right into the shell. These will as well, minus the ones that have to do with arguments. So process ID will work if you run a script and then pipe process ID, or if you run a larger command. Um, I do believe the return code also works, and the entire last command, the exclamation exclamation, does work as well. That one I tried out and it worked for me, which is actually pretty useful. So you don't have to keep hitting up arrow in your terminal for 3 hours trying to find that one command you typed. So now that we've covered variables, the next bit of any higher level programming language is control flow statements. So you've got if, and you've got switch statements, and you've got for loops and while loops. And it works the same as it would in most programming languages. It looks very similar to the syntax for Python, for those who've worked with Python. So for loops are for, and then whatever name you want to give for your current value you're iterating at, your current value you're at in the loop, in, and then file or the variable you want to loop through, or maybe you have a list of numbers. And lists are denoted by curly brackets and on either end, and then commas, very much like an array in C or Java. Um, there's not really a lot of use for lists like this, at least with numbers. But lists can be useful for file names, extensions, uh, specific character groupings, etc. And so for loops, you have the for, x in y do. And then after the do, you put your lines of code that, you know, oh, for all these files that you find, for, X and Y, print out the value or delete the file, or, you know, move this file from one device to another. And then you have the done. Once the loop will not end, or at least the code for the loop won't end until you hit done. It will keep, basically the loop will keep searching. Like it'll be on, let's say it's going through, the list of numbers. So it's at one. It will go for, numbers in this list. All right, well, the first one is one. So we'll do something with the one, and then it will keep looking for code to execute unless you have that done. If you don't have that delimiter, it will just break. Same thing with the while loops. It's just while, and then you give it a condition.
I have one question.
Yes.
So you have to encapsulate doing it done, right? So you required for the code side the do and done indent properly?
From what I could tell, it doesn't have to be. Um, because white space doesn't really matter. As long as those lines of code exist in between the do and the done, it should work.
Okay.
That may not be in, I know a lot of people will indent it just to for readability, but I didn't see that having an effect on usage.
Yeah, I don't think you need to, because like for one-liners, you just have the semicolon in between.
Yeah.
Okay.
Which is the other thing to note about semicolon. I glossed over it, but you can technically write entire bash scripts in the command line as a one-liner if you use the semicolons. Why you would do that, I don't know. You're mad lad, but it is possible to do.
It makes things quicker sometimes. You don't have to like run a file.
Yeah.
I assume for hacking tech.
Yeah.
Yeah, if it's basically if you're doing a very specific like tool or doing a lot of, you know, grepping and concatenating.
Okay. All right. Thank you.
So, fors and whiles work exactly like you would expect them to um, in other languages. So nothing too special there. Then the next part of control flow, you got if statements, and you just have your if, you have a conditional, and we'll get more into the syntax of this conditional here. Um, So you have an if, and then you have a then, and then you have an else. The then is the true case, the else is the false case, and then the fi is the finish. That's how it knows that the if statement is done. That's the closing, finalization of the if statement. Just like with the for loop and while loop, so the code doesn't just try to keep running and then you break, and then you've now have a shell script that doesn't work and you're ripping your hair out. I've read that this is a very common thing to forget, both in the for and while loops, forgetting the done, and in the if statements, forgetting the fi, because it's something you don't have to do in other languages. Because in other languages, it's either, oh, it's all in the curly braces, or, oh, it's, indented, and it's super easy. With Bash, because it's so freeform, people tend to forget the done and the fi when it comes to if statements and for loops, and that tends to mess people up. But again, works exactly like you think it would. If, then, you can nest if statements. So part of the syntax of your evaluation and conditionals is you have all these wonderful tools for evaluating stuff. So you have tac lt, which is less than, tac gt, which is greater than, tac le, which is less than or equal to, tac ge, which is greater than or equal to, tac eq, which is equals, tac ne, which is not equals, and it works exactly like you think it would work in programming languages. It evaluates and compares. So, for example, I'm going to go back to the last slide. This one I actually made a little mistake. You don't need that equal sign there. That was a typo on my part. So ignoring that equal sign, you have a variable, which really should have double quotes around it, but for the sake of brevity, variable, and then you're saying, hey, tac equals 2. So if that variable is equivalent to 2, then do whatever, else don't do something. And so you can do this, you can even set it equal to not just a number, you could set it equal to a string, you could set it equal to another variable, you could check and see if it's equal to the output of a command. You can also do some weird stuff with, special variables and other commands and piping, and you can do a really complicated conditional if you really wanted to. But if you're getting complicated like that, it might be best to consider not using bash scripting and maybe using something with a little more beef behind it, like Python or Perl, simply because bash scripting's not meant for super beefy tasks. It's meant for automating command line stuff, automating everyday command line tasks, automating common things that you do, automating annoying things to type out. So if you're trying to do something really beefy and trying to parse a file with bash, you can. You have the if statements, you have, for and while loops, you have a lot of variables that you can use, but really you should just stick to, basic stuff. So one note about using these control flow statements, kind of like using the double equals sign versus a triple equals sign in some languages, or single versus double in a lot of compiled languages like C. It's the accuracy of the quality and how much scrutiny is going to be given to it. So in Bash, use double brackets. You can use single brackets like I did in the if statement example, but that can lead to problems with floating point values, with strings, with command outputs. So the advice is use double brackets and just make that a habit, because at worst case, it does nothing and it's taking you 2 extra seconds of your time. At best case, it will keep you from math errors. So double brackets when doing equalities, just to make sure that you get accurate results. No bad math. The next bit that's really cool is you can use commands as kind of variables. So bash scripting, not only do you have like the basic tools of the simplest of programming languages, but it's really meant for calling commands and using commands. So you can call commands as variables. So you do that by having a $sign, open parenthesis, your command, and a close parenthesis. So for example, you can use that in a for loop. So for file in in ls, do something with it. You can, grep and take that value that, is returned, all those files that are returned that you grepped, and you can then put it into have a bash script that will parse it and look for specific parameters, look for specific things. You can do that with cat. It's really useful for like the move command as well. You can take, hey, did it move? Was there an error with moving it? Because it will return what the command returns. So you can use all that to your advantage. You can also compare the outputs of commands, or another way to pipe one command into another. You can nest it, so to speak. So for example, I have this ls command here. I could nest, another command. Like I could say, oh yeah, cat this text file, and then use that text file as the arguments for the ls command. Or I could go, hey, grep the output of this command. Whatever useful utility you have, whatever you want, you can do that, and you can denote it as variables so you don't have to type out really long statements in your bash script. And one-liners are great, but they're hard to read, and they used to give me a headache. Some people are absolute crazy and can read them, and more power to them. They're beautiful people. So the next special thing about Bash that's a really useful tool is you have the ability to use wildcards. And so you have the asterisks, which that will substitute anything, any value. This one's used a lot in the command line, just in straight CLI. I don't know what file I'm looking for, but I know I'm looking for a PCAP file or a PDF or a PNG. So you'll do star dot, PNG. Or in my example, I have, JPG. And so it will delete all those files with that extension, regardless of the name. Because the star, the asterisk, it's wildcard. Does not care what the value is. You can even do weird stuff like star dot star, and it won't care about the file name, and it won't care about the extension. It will just delete everything. Basically, at that point, just do rm tac rf. But the other wildcard you have is list substitution. So it goes back to those curly braces, and you can say, hey, I want to delete all those hello world files I've been doing because I've been learning HTML and Python. I'm a real hacker now. And then you realize that you're not really a hacker, and HTML isn't a programming language. So you want to delete your shame. Well, you can wildcard all the extensions, so your TXT files, HTML files, Python, and that will only delete things that are in that list. You could also put the list as the name, but a lot of people, and if you've ever gone to Stack Overflow, you'll know this, are very hostile towards people doing that, because the collective brain has decided that that's not very intelligent, and unless you know exactly what your file names are, then don't do that. And if you really want to delete specific files, or names of files, but you don't know the extensions, then just use a star for the extension. That way you're not sitting there writing out a list of every file you've LS'd. Now, could you make that easier by saying, hey, I have this, going back to previous slide, I have ls variable, and now that this is now a variable, this is now a value I can use, $ls, I could then put that into and use that as my list. Yes, you can do that. But at that point, there's other utilities you could use. You know, evaluate what you're trying to do. There's probably a simpler way to do it. It might just be to delete the folder. It might just be to search for a smaller range of items. So a little bit of thought can go a long way to optimizing the scripts. Sometimes the most simple solution is the best. Of course, you can combine the wildcards, so you can delete, rm star dot, and then you have jpg and png. It will delete any of the JPEG and PNG files, but it will leave all your GIF files alone. MP4 files, HTML files, etc. Really useful. Of course, you don't have to use this just with RM. You can use it with, like, say, the grep command or cat command to make sure that you get only files that you actually want to look at. I know a lot of times for CTFs, for instance, they love to give you like giant zip files full of just garbage, or they'll give you a PCAP and you'll export the files and it's just 1,000,005 HTML files and you just want to scream. Wildcards are really useful for that. Whether you have an actual bash script assisting you that you've written, or whether you're just doing one-liners in the CLI. So a lot of useful commands, and this isn't all of them. This is just a lot of the ones that people use a lot. I personally use a lot when I'm on a Unix system. But there is a lot of commands, and there are a lot of utilities as well that are super useful. So definitely look around, because if you could think, man, it'd be really nice if I could do this, or man, this tool really stinks. Because, the open source community is very diverse, and there's a lot of people who like to do things for themselves, and a lot of people who like to have things different ways. There's probably at least 2, 3, 4 alternatives for any given tool. And also be aware that some of these commands, while they're mostly universal, may not be available in your system. Void OS. So you have echo. It's your print statement. It prints stuff to the CLI. You could even type echo in the CLI, and it will just echo back to you what you typed. grep is really useful. It searches for text patterns. It's great for capture the flag competitions. It's great for reading log files. It's just super handy. Honestly, grep is a lifesaver. You have man, which is probably one of the most important utilities and should exist for every command line tool, every program you have on a Unix system. If it doesn't, it's a very sad thing, and the developer needs to make one, because it's the manual for the command. Some commands it's a little wordy, some commands it's a lot to read through, and you have to page down 1,000,000,005 times in the CLI to find the actual how to use the command. But this is going to be your lifesaver to remember the man command, because you just type man and then you type in whatever your command. So man echo, man grep, man pwd, man rm, man aptitude, and it will tell you all about how to use the command. It's beautiful. You have pwd, which prints the current directory, and it will print it out in the common format with the slashes. So /bin, /etc, /source, etc. ls, it lists the contents of your current directory. Locate, which is to find a file directory. So you do, I always tend to forget where yeah, command duel, yeah. Um the I always forget where stuff like, is that in bin? Is that in source? Is that in etc? Where's the config file for this web server? Where's the bash RC? You can just locate it. I didn't learn this till a couple months ago, and I beat my head into a wall literally because I felt like an idiot because that command is so useful because I don't remember directory structures, but use the locate command, it does the work for you. Cat, it allows you to read files or smash files together. Really useful when paired with grep, especially for capture the flags and other kind of log analysis, configuration management. Of course, you have history, another very useful command. So instead of pressing on most command line interfaces, on most shells, you can press the up arrow or the back arrow, and it will give you the previous command you typed, which you can be doing for hours. But you can use the history command. And I see actually a very common bash script a lot of people write is they write a bash script that will run and show them a list of commands, the history of their commands, and will show them the most frequent and most recent. They call it frequency. A lot of places, I don't know why they put those words together. That just sounds horrible to say, but frequency of commands. So they'll make a bash script that does the history, and then we'll use extra if statements and variables and parameters to figure out and sort them by not only how often you use them, but how recently you use them. So that can be really useful and save you a lot of time. And that's the whole point of bash scripting, is to take all these kind of tools, take all the stuff you would do on a command line on a day-to-day basis, and make life easier for you. Make it so you don't have to type for 3 hours. We also have the clear command. It clears your terminal window, keeps it from being messy. I find it useful to do every now and again. Like when I reach a good stopping point in what I'm doing, or like a good bookmark point where I don't have to scroll up to reference stuff, I'll do clear. That way it just keeps the terminal fresh, keeps it clean, keeps it from being a problem. And clear does not remove your command history. It does not, stop process IDs. It doesn't stop any running programs. It just clears your terminal, makes it nice to look at, so you don't have to close it and reopen a new one. Kill, it kills a specific process. So very, very important, not only to know from, say, red team, blue team's perspective, like if we do the CCDC competition, or if you're doing a Pros v Joes thing, knowing kill and being able to just, kill whatever the process is and shut stuff off. But also, it's good for keeping yourself clean and keeping your system from slowing down. Because especially I've noticed, for me, when I've done a lot of stuff with reverse engineering and some programming stuff, I end up running a lot of processes and a lot of duplicates and stuff that I don't need to be running anymore actively, but it's still going in the background. It eats your memory, and it eats it eats all those wonderful clock cycles from your CPU. So kill your commands. Don't leave stuff running. Be respectful to your system. And probably the coolest command out of some of the more basic universal ones is alias. And fun fact, a lot of your commands in the CLI are not actually the call sign or command for the utility itself. They're an alias. And an alias is quite simply, you say, hey, alias this word, and then here's the command I want you to run. So, for example, and hopefully this will come up. Let me switch my screen so you guys can see my wonderful VM. All right, so my VM is up. Let me know if you can't see it, but the stream preview says you can. So I'm going to trust Discord. So let's go to our terminal here. So you have your ls command, right? And that's normal ls command, you know, desktop, downloads, documents, pictures. Okay, yeah, cool. Alias, if something is already aliased, already has a value, already has an association, it will show you the association. If it doesn't, you can make one. So alias ls, you see here, and let me see if I can zoom in. So alias ls is equal to the ls command with a parameter, color auto. So that's not actually the real ls command. The real ls command doesn't actually have color. So if I do ls color equals none, so if I do the opposite of the auto parameter, it gets rid of the color. So those two, the one that's in the aliased version, I'm calling the command and I'm countering it out, and it then goes back to what it should be like, what it normally would be like if you ran it just raw, unaliased, on anything. So let me clear this.
Is there a Windows equivalent to this?
I didn't. I honestly don't know.
Because the power move is switching all the Windows commands to the Linux commands, and then you only have to learn one command line.
So it looks like in just a brief Google search, it looks like there's a way to do it with environment variables and text files. So you can do it, but it doesn't look like there's a native way. But yeah, so alias ls, it's the ls command, but with the color auto parameter, which, so every time I type ls, it's always going to have color, because it's not calling ls, it's calling the alias, because the alias will get interpreted first. So if I unalias ls, and this might destroy me, but whatever. So now it's unaliased. ls is no longer a special code word for anything. No, it no longer has color, because it's, not, ls is now associated just with the program, just with the application, just with the tool list, or ls. It's not associated with the special whatever you wanted to write. So I could write an alias for, make sure I get the syntax right for this, alias John equals ls color auto, because that's readily available. Hopefully I'm doing this right. All right, and then if I type in John, so ta-da, you can change the name of commands. It's beautiful. It's gorgeous. And yes, one way to find out. Don't have Wiki installed. Yeah, my VM, I had to destroy it. So let's see, bash RC. Let's just go to it. It's in. It's. Oh. Yeah, home, and then it'd be test, and then it should be. Dash ALT, yeah. Yeah, that's right, because bash RC is a hidden one. Screw you, bash RC. Oh yeah, that's right, because it's hidden. Gosh darn it, I don't like the hidden stuff. Yes, it does. It does change some. So those are some. Notes on alias.
Oh,
So it looks like it has some. It doesn't look like it changes bash RC. I did.
I was thinking, like,
Yeah.
oh, this could be bad. Like,
So let me try this. So this is the window that I unaliased LS in. Let's try this one. Do a little bit of science on camera. This never goes wrong. All right, so it says LS is still aliased. So it looks like alias is just for that session. I think there is actually a way. I'm remembering now. There is a way to save it to bash RC.
probably just
Yeah.
I mean,
Yeah,
I
you
think the
do.
reason it doesn't is because it can unalias, so it
Yeah,
doesn't bash RC.
that's probably exactly why.
To keep default, to
So
keep a backup almost.
that's
funny to do.
that would be hilarious.
I mean,
Yeah.
Like
red team could just
rebind.
yeah. I mean, think
I
about
mean,
it.
you could hide
Take out the
Echo.
red team and you just alias kill, so they can't kill anything.
Oh, that'd be beautiful. I mean, okay. Isn't if I'm remembering correctly here, and I'm remembering this because where did I hear this? Back in high school, I remember hearing something about this. Isn't the current running terminal, doesn't it store its configuration like an attempt file? So you could just, you know, sneakily make the temp file bash RC, call it a day. Or you could can you do it? Ooh, could you save the temp file and then change the linkage from the terminal to bash RC sneakily?
Yeah,
So your temp, so you could either have a hidden terminal running, which has its own temp file with all your configurations, and then you could link. You could change the linkage from bash RC to your temp file, which unless they find your hidden terminal process, wouldn't be detected, and they wouldn't know. They'd be just confused. Or you could save the temp file as bash RC or instead of bash RC. Gonna have to play with that a bit. That sounds interesting. I feel like this is probably something that's definitely been patched and taken care of because it seems a little too obvious. Seems a little too easy. But yeah, alias is cool. You will have to echo it into your bash RC to save it permanently. Or just type it in yourself like it is here. So here's the alias for ls, which is the same as over here. So I were to delete this. Ooh. Well, I have to actually open bash RC. But if you were to delete that, then it would actually be deleted, and then it would be the same as unaliasing it. But yeah. There's a lot of other useful utilities too. There's one called shell check, which is spell checker but for the shell, which I haven't used, but I looked at it and I'm definitely going to start using it because it looks like it could be handy. But yeah, so go around and explore. Uh, look up commands, look up utilities. You want to do something, someone's probably developed a tool for it, and it's a command line tool. Like for example, locate. That doesn't come default on Ubuntu. I know it comes default on Arch. But just install the tool and then start using it. You can't figure out my password from my keystrokes. I dare you. So while that's installing, I'm gonna open a new window. So I do have an example of what a bash script looks like. So I'm gonna open this up. Yes, for those of you who love Vim or something like that, I'm sorry. I'm using GUI text editors. You can hate me in the comments. So this is kind of what a basic bash script would look like. And again, white space doesn't matter, so I could have more spaces in between these if I wanted to. And it would still work. But we have this first bit, which I didn't talk about in the slideshow, so I'll talk about now. This is the environment variable for bash, and this just tells you what interpreter. It tells the CLI what interpreter you want to use. So if you wrote your own custom bash interpreter, your own custom shell, instead of bash, your own modifications, point it to that. Some systems will do this automatically and will automatically assume that you're using born again shell, bash shell, but some systems don't, some OSs don't. It depends on how they're set up. But if you include this, the bin bash, it should make it agnostic to most Unix systems that use bash. Obviously, if it uses ZSH or fish or something like that, then it's not going to work until you install bash on that system. But that just helps with any kind of usability and portability of your script, so it doesn't break between your VM usages, so you can put it on your friend's computer easily. Next is, of course, we have a variable declaration. So variable declarations, again, are just, here's a name, here's what it's equal to. And don't judge my dyslexia. Then you have an echo. And I'm not doing anything with this variable, as you can see, but I could easily do that. So if I wanted to add that, I just do echo $, because I want to say, hey, this is a variable I'm referencing here, HW. And this echo here, this first one, is saying, hey, I want the ls command, but I want it as a variable. I'm using this ls command as a variable for echo, because echo takes variables and prints them out to the command line. So, before I forget, make sure you got your quotes around your silly little echo in your variables when you use them. You don't have to do that for command variables, but for literal variables you do, just so where it knows that you're talking about a literal variable. I don't think with echo it matters so much, because echoes are like really primitive, but it's a habit to get into. So as long as the demo gods like me, this should work. And this is a simple demo, but demo gods seem to hate people. So testscript1.sh. So you do the / to go run your command, and then you specify it. I am in my home directory, so I don't have to cd to it, but you would have to cd to it if you wanted to use it wherever it's at. And there we go. So it prints out ls command, and it prints out the wello world. Say that 5 times fast. Wello world. One thing to note, and this is why I disincluded it. So let me comment this out, which comments work the same as in Python and in Perl. It's a hashtag. So comments are hashtag. A lot of configuration files use this as well. So I'll comment out that echo of the variable. I just want to look at the ls for a minute. So let me go back to my terminal. I'm going to rerun that script. Notice how I'm running the ls command. I'm echoing the ls command. But then it's printing it out white, all white, no color. But then when I run ls in the terminal, it has all the color stuff. That's because when you're running it in a bash script, it's not being run, it's not talking to your bash RC file. It's just referencing the actual command itself, the actual utility itself. So that's something to keep in mind, that bash scripts will not inherently run your aliased commands. So if commands have a slightly different output, that's why. Because a lot of commands are technically aliases of the actual utility. So just something to keep in mind, something to note. So with the other script I have, where's that? There it is. Oh, Arguments. You can pass in arguments to use. So for this script, let me open up terminal. Excellent. This one's done, so I can just use this one again. So test script 2. /test script 2.sh. Permission denied. The one last thing that you have to do when you make a bash script is, of course, include your hashtag bin bash so it works universally. Don't have to worry about compatibility unless, of course, your system doesn't use bash. Then it won't work. Doesn't have the interpreter. Then you type out your code. Again, keep it to one-liners, or if you do one-liners, keep it with the semicolons. Otherwise, it won't work. Or each thing has to be on its own line. When you save it, make sure it's a .sh file. When you want to run it, just like you would for a lot of other executables in Unix, run it from the terminal with a /. But because a .sh file, when you first make it, is just a fancy text file, although it recognizes the .sh that, hey, this is a list of commands I can execute, it won't execute them. Because unless you have something natively configured to change this, which I don't know why you would, because that just sounds like a vulnerability waiting to happen, you don't have execute permissions on a text file. So you're going to have to become a super user. So sudo -. Ta-da. I already typed sudo earlier because I did the apt install, but you would have typed your password. You do chmod, and you want to change the permission to execute. So it would be chmod +x. So I want to change something to have the execute permission, and the something I want to change to have execute is testscript2.sh. No errors. I'll assume that it worked. So let me escape. You don't have to run shell scripts as sudo. The only time you would is if a function call, a CLI command that you're using in your shell script requires it. So if you're running like apt-get, you would probably need to add a sudo. In fact, you should add a sudo. That way it will not give you the error of, you're not the super user, and then you get frustrated and you fail to type, you get frustrated, and then you don't type in your super user password correctly, and then it locks you out. It's a nightmare. So /testscript2.sh. It should now work because I've given execute permissions. Oh, expected tokens. That's right, because if you look, I am accepting these special variables, $1 and $2. Those are arguments. So I've got to pass, it has slots for 2 arguments. So let me push up arrow, I'll run that command again. So the first argument it's expecting is just, we can look at the code here. It's just, it just wants a variable to print. So I'll just write O'Leary, because why not? And then it's looking, the second one is looking for a argument for the ls command. Okay, so let me do test folder 1, because that's one of my folders in my home directory, test folder 1. So then I will hit enter. Did I get that backwards? Syntax error. Why are we getting syntax error? You worked 5 minutes ago. Demo gods. Demo gods, why do you hate me? Why do you hate me so? It's a problem with this line. It's a problem with this line. Let's change this around a bit. Maybe this will work. It worked literally before the presentation. I feel ashamed.
Oh, did you
It didn't save it. It didn't save it after I edited it. That's why. Yeah, so there you go. But I don't know why that was a problem. Do not need quotes around an argument. Did I make that silly? Did I make the silly with that? Because arguments are special and aren't like other variables. They aren't literal variables. They're just arguments. Did I make that silly mistake? No, okay, that's not a silly mistake. Okay, I don't know why it's not taking the first argument then. Okay, whatever. Yeah, it didn't work with quotes either. That's how I had it originally. I don't know. So whatever. I don't know why that's not working, but probably did something goofy. But yeah, so if we do this, it will ls, it passes my argument, which is test folder 1, and it'll echo out the ls command. So whatever the contents of test folder 1 is, and it's going to echo out done. Not a very fancy script. I had a fancier one. It actually went through one volume, copied over all the images. It then put them into a tarball and then moved it to another volume. And the idea was that it's a backup script. And you can do that with Bash. And that's one of the more complicated things that you could automate. So instead of having to type out, oh, great, I have to go to this directory, I have to copy all the stuff with that, all my picture files, and then I have to tarball them, and then I have to move it to this other volume. You could write a Bash script, automatically backs up your stuff. You could even set up the script itself, because the script is executable. Set up the script as a command. You could do a symbolic link to the script. So instead of having to do // you could just have a symbolic link and have it automatically run the command every time you do the link. Or you could just run it every time, keep it in your home directory, keep it in your root directory, run it. You could set it to run as a process and have it run periodically, whatever you wanted to do. And actually, if I'm, yeah. So that's kind of the basics of Bash scripting. Again, these aren't very complicated scripts. They're more of the hello world variety. My other scripts got destroyed. Thank you, AMD. Very cool. But there's a lot of cool examples you can find online of cool stuff people have made with Bash scripts. A lot of cool tools, assistants, and aids just to help with automation and daily tasks on Linux. And fun to play around with. And a lot of the syntax and a lot of the rules for Bash scripting will apply in CLI. And you can technically write them one-liners like me and Zach were talking about. It's useful. It's quicker. But if you find yourself doing that a lot, you probably should save it as a script. Plus, Bash scripts, they also even have, with the right utilities, you can have GUI. For example, for those of you who've set up Raspberry Pi, and it has if you SSH into it, if you do the SSH setup, not the GUI setup, and you go into the CLI, a lot of the utilities you use and you can call a GUI, like one of the things is you can have a GUI-esque appearance to your shell, to your terminal window, to configure like wireless settings on the Pi and configure some password settings, user settings, etc. And it looks kind of like a GUI, or it looks like the very primitive installer. Ubuntu has the fancy, ooh, look at these colorful lights and sounds, but there's also the really primitive ones. For example, if you ever installed Kali Linux from scratch, Kali Linux still uses it. That's just a fancy shell script. So you can get really complicated. You can use a GUI with it. And it's very useful for either, like with installers, when you don't have any other utilities on a system, or you haven't gotten that far, you haven't established network connectivity, so you can't download the latest Python interpreter, download, GCC, whatever. It's useful for a very bare bones system and it's useful for simple stuff, simple menial tasks that you just don't want to type. And that's what it's meant for. Same thing with Windows as well, with batch scripting. Windows PowerShell is a little different. That one is going to be really robust because PowerShell, they it's a scripting language, but they've made it to be a fully fledged programming API tool. And if you really want to have job security and be really good at blue team, red team, sysadmin, network admin, whatever it is, PowerShell is really good to know. And is something that's worth taking the time to know. So with that, I don't think I had anything more. Oh, I did have one more thing. Those of you who like entertainment, this was the contents of test folder. Yeah, behold, behold, beautiful, gorgeous
Amazing.
things. They're top tier, top tier. Only the best things on my VMs, of course.
Absolutely.
I hope maybe I could appease the gods with it.
I need to press the button mark smite. Where is it? Gotta be available in Discord somewhere.
So yeah, that's week 2 of the missing semester and shell tools and scripting and all the wonderful things that you can do with it and that you will be forced to do with it.
Have any questions for John? Okay. Well, again, I would like to thank you all for spending time Saturday. Also, share the chat, download it, stuff.
And
have
do
this.
I'll save it as PDF.
I'll have this video finished, edited, it. Um, again, I'm gonna end the recording now.